All right, this is going to be part 2 of the review sheet for the summative, which is on Thursday. All right, for question number 5, we're looking at transformations. All right, we have given a function where it's been transformed by, on the inside with -1, and on the outside with -4. So on the inside, that means that we're going to go to the right by 1. Outside means we're going to go down by 4. What we're supposed to do is take the graph that we're given and then transform it using those changes. So I'm going to use these 2 points here. I'm going to go to the right by 1 and down by 4. And this point right here, I'm going to go to the right by 1 and down by 4. All right, the other point is not really on a corner of a grid, so I'm not going to use it to transform it. I'm just going to use those 2 and then go from there. So that was that graph transformed down to the right by 1 and down by 4. Do the same thing with the next one. This time the transformation on the inside, the +7 is going to go to the left by 7. The +9, I don't know what that was. It's a 7, there we go. And then the +9 means I'm going to go up by 9. Again, I'm only going to use the 2 points. I'll start with this point. I'm going to go left by 7 and up by 9. On the other one, I'm going to go left by 7 and up by 9. So then I'm going to use these 2 points as my graph, and there I've transformed both graphs from the functions. All right, number 7. So solve the inequality. So this is going to be a multi-tiered problem. All right, first thing you should see in this is that out of 2x cubed minus 4x squared minus 48x, every term in here has a 2x in it. So we're going to take it out. We're left with x squared minus 2x minus 24. From that quadratic, we got to factor it. So we're going to figure out what 2 factors multiply to give you -24 and add up to give you -2. Gives you -6, +4. Don't forget the 2x on the front end because that's an important piece. Now that we've got it completely factored, we're going to set each one of the factors equal to 0. Solve for x. So x will equal 0, 6, and 4. Next we graph it so we can see what parts are less than or equal to, just like our inequality says in the problem. So we have, oops, sorry, this is -4. All right, we have -4, we have 0, and +6. All right, looking at the first part of our equation, the 2x cubed is a positive number, so that means our graph's going to look like this. Okay, and what we're looking for, based on our inequality is less than or equal to. Looking for the parts of the graph that are less than or equal to 0. So the parts that are below the x-axis. So here and here. I'm going to write those answers in interval notation. So what are the intervals for that along the x-axis? So going to the left, it goes from -infinity, and it stops at -4. Now, infinities always have a parentheses, but the -4, because it's less than or equal to, is going to have a bracket. So it stops at -4 and starts up again at 0 with a bracket, again because it's less than or equal to, and then stops at 6 with a bracket. And that is your answer. For part B, you have a quadratic. To get a quadratic, you're going to subtract the 72 to the other side, greater than 0. Now that we have our quadratic, we're going to factor it. So what 2 numbers multiply to give you -72 and add up to give you -9, or -1, sorry, which is -9 and +8, Freudian slip. All right, set them both equal to 0, and then solve. Again, we're going to graph them. So we have -8 and +9. Since we know the x squared term is positive, our graph's going to look like this. Now, based on our inequality sign, the sign says greater than, so we're just looking for the parts that are above the x-axis that are greater than 0. It's those 2 right there. Now I'm going to find the interval notation of this. So going to the left to right, left is negative infinity. It stops at -8. And this time, because it's just a greater than and not an equal to, it's a parentheses for both. All right, between -8 and 9, it's not greater than 0. But starting at 9 with a parentheses, it is greater than 0, and it goes all the way greater than 0 till you get to infinity. And there's your answer for part B. Okay, next we're going to do some of the word problems. Okay, so one thing about these word problems, there's two different equations. I'm going to show you both. Okay, the first one is A is equal to P, the principal, times 1 plus the rate divided by K raised to the K times T power. So as we're reading this question, we want to figure out what these parts are. All right, so Johnny starts a savings account at the local bank for his daughter. He starts with $1,000, and the account has an annual rate of 4%. So we want to write a function. So our function is A, amount over time, equals the principal, which is 1,000. Okay, the 1 is part of the equation, plus the rate at 4%. We're going to convert into a decimal. So if we do that, it's going to be 0.04. Okay, now the K value, because we're doing an annual rate, annual means once a year, so that means the K value is 1, which we don't need to write down because you're dividing 0.04 by 1, which is just 0.04. Raising that to the K times T power, again, because K is annual and it's a 1, it means we don't need to write it down when we multiply it by T. Now, if your problem says like monthly or weekly, then your K value would be a number that wouldn't be 1, and then you have to write it down. So for example, monthly would be 12, weekly would be 52, whatever it might be. In this case, it's annual, so it's only 1. Okay, so now for part B, we take that equation. I'm going to combine those to be 1.04 to the 18 power. Now, you should be able to do this on your calculator. If you don't have your calculator available to you, you can always go on the Calculate 84 app that you should have downloaded before we left school. I would put it all in at once at the same time. Otherwise, you're going to have some problems. So you have 1,000 times 1.04 to the 18th power gives you 2025.82. There you go. All right. Number 9. Okay, we're going to use the same equation we did in number 8. Okay, in 2005, there were 285 cell phone subscribers in the small town of Centerville. Number of subscribers increased by 7.5% per year since 2005. So write your function. So we have subscribers over time equals the principal, which is 285 in this case. All right, and then 1 plus your rate. So you have 7.5%. Turn that into a decimal. You're going to get 0.075. So you put that down in there. All right, again, because we're doing per year, that's once for a K value. So your K value is going to be 1, and then K times T is 1 times T, which is T. So we put this into part B. We got 285, 1.075. All right, another important piece out of this problem is the since. So since 2005 means you don't count 2005 in it. So it's 2020 minus 2005 gives you a total time of 15. So again, you put this in your calculator, you got 285 times 1.075 to the 15th power, which gives you, as a whole number, 843. All right. Now question 10, sorry to tell you this, we're going to change this question by one word. We're going to go increasing. The reason being is because we didn't really go continuously decreasing any examples. Okay, so we're going to show you continuously decreasing. Now the reason we're doing that, I'm making that change is because the continuously, that is a key word that tells you it's a different type of equation. And that equation is going to be A is equal to the principal times e to the RT power. Okay, so because it's continuously, that means you're going to use this because the e is the continuously part. Okay, so when we're writing our function, we're going to put that stuff, the values, into where they belong. So the population over time is 675,000 times e to the r. The r is 1.27%, converted to a decimal, 0.0127. Okay, and then the time is t. We put that in our problem down here. We have 675,000 times e. Again, e is a button on your calculator. It's second, and then the divide sign, or divide button. So we got 0.0127 times, so again we have, where is it? There it is. We have since 2000, so it's between 2030 to 2000. That time frame is going to be 30 years. So again, we put this in your calculator, 275,000 times e to the 0.0127 times 30 power. It's going to give us 988,029 people. We're going to round to the nearest whole number. Actually, for population, we're actually going to round down because you can't round up a person. So I'm going to leave it as 29. And there you go. All right, so another quick reminder, if it's continuously, you're going to use E. If it's not continuous, you're going to use the K values, whether it might be annual or monthly or weekly, whatever it is. All right, for 11, there's 4 equations. Now, these are a review, but they are going to be on the test. I'm going to tell you that right now. So you got to know how to do them. So for the first one, we have a problem. We got 2x to the third minus 50x. Both terms have a 2 and an x in them. So we take them out. Be left with x squared minus 25 equals 0. Okay, now the x squared minus 25 is a specific type of factoring. It's called the difference of two squares because both x squared and 25 are perfect squares. So what two numbers multiply to give you negative 25 and add up to give you 0? It'd be negative 5 and positive 5. The 2x has to go out in front as well. If you set these all equal to 0, and then solve them, you're going to get 0, 5, and negative 5. For part B, these are both perfect, or difference of two squares. So two factors that multiply to give you negative 49 and add up to give you 0 are 7 and negative 7. And the factors that multiply to give you negative 9 and add up to 0 are negative 3 and positive 3. If you set them all equal to 0, which I'm not going to write out, and solve them for x, you're going to get 7, negative 7, 3, and negative 3. All right, for part C, these are radical equations. In order to solve these, you have to get the radical by itself, so we're going to add x to both sides. And now that the radical is by itself, you're going to square both sides. Squared and the square root will go away. You're left with x, or 6x minus 5 equals x squared. Okay, now you want to get everything on one side, and then rather than subtracting x squared and making it negative, I'm going to subtract the 6x and add the 5 and make everything go to the right. So we're left with x squared minus 6x plus 5 equals 0. Okay, now we're going to factor factor the quadratic that we're left with. Two numbers that multiply to give you positive 5 and add up to give you negative 6 are negative 5 and negative 1. Okay, so negative 5 times negative 1 is positive 5, and negative 5 plus negative 1 is negative 6. So we solve them both for x. We're going to get 5 and 1. Now, because these are radical equations, we have to check them in the original question to see if they work out. So if you put 5 in for x, you get 6 times 5 is 30. 30 minus 5 is 25. The square root of 25 is 5. And 5 minus 5 is 0. So that checks out. All right. And you put 1 in there. 1 times 6 is 6. 6 minus 5 is 1. The square root of 1 is 1. 1 minus 1 is 0. And that checks out. So these both work. All right, the next one. Before we can square both sides, we have to add 9 to both sides. So we have the square root of negative x plus 6 equals x plus 6. All right, now that the square root or the radical is by itself, we can square both sides. Square root and square root go away. We're left with negative x plus 6. On the right-hand side, we have to multiply x plus 6 times itself. All right, when we do that, we're going to multiply using distributive property. X times x is x squared. X times 6 is 6x. 6 times x is also 6x. And 6 times 6 is 36. Okay. Again, to keep the x squared term as positive, I'm going to add x and subtract 6 to the other side. So we're left with x squared. 6 plus 6 plus 1 is 13x. And 36 minus 6 is positive 30, equals 0. We can then factor this quadratic. Factors of 30 that equal 13 when you add them together are going to be positive 10 and positive 3. Solve them both for x, negative 10 and negative 3. Again, as a radical equation, you have to check these to make sure they work. If you put negative 10 in for x, negative 10 times negative 1 is positive 10, plus 6 is 16, the square root of 16 is 4, and 4 minus 9 is 5. Okay, and then if you put negative 10 on the other side again, negative 10 minus 3 is negative 13, and negative 5 and negative 13 are not the same thing. If you put negative 3 in for x, so negative 3 times negative 1 is positive 3. 3 plus 6 is 9. The square root of 9 is 3. And 3 minus 9 is negative 6. On the other side, negative 3 minus 3 is also negative 6, and this does check out. So negative 3 is your only answer. And that brings us to the end.